So good evening, everybody. How are you? So how was your test 3? Yeah, I told you that will be coding mostly. And so you know that your final will be on 4th, December 4th, right? Okay, December 4th, that is maybe 6 to 8 p.m., 2 hours. Do not forget, okay? I have my schedule for 2 hours. I don't know yet how long the test will be, but I'm sure it will be longer. And look for look in the syllabus whether it is a cumulative or the last few sections. It's the final?
Yeah.
Week 11 to?
That's for final week 11 to 16.
Okay, so let us have a quick review on that one. So what is that one? What did you get that? So first year experience on page, that page? The schedule? Did you get on the schedule page? So this is my schedule, right? Okay, so in the final, oh, it says week 11 to 16. Okay, so week 11 is exception. Okay, and file IO, thread and parallel processing and binary search tree. Okay, so 1, 2, 3, 4, 5 topics. Okay, and I see that I have to complete, what is this called, binary search tree even. Okay, according to the schedule, I have to discuss binary search tree tonight, but I'm not so far yet, because you know in the last class the exam test 3, so I could not teach anything, and also I expected to teach more on threading, especially thread synchronization. I want to cover thread synchronization and parallel processing tonight, and in the next class hopefully we will discuss about binary search tree and binary search tree, and then next 2 weeks we'll, okay, then there is a Thanksgiving break, right? After the Thanksgiving break I will not teach anything new. Okay, whatever you ask me to review, I may review that. Okay, because but I believe your Thanksgiving break will not be really a break. You have to study and you have to review a lot, right? Then you have other exams. So I know Thanksgiving break are not good for students. So you need to spend all of your break hours. You know. Okay. So did any of you have had a chance to review multi-thread or threading problems? I created a repository, like or in my book chapter, chapter 18 was mostly about threading and multi-threading. So if you go here and download this code and then do some practice, then it will be better for you, okay? But let me go through this thread synchronization. So before I come back to this slide, let us go to the next slide to understand what is thread synchronization. What is thread synchronization means and why it is needed. Actually, in the previous example programs, we showed that, okay, we showed that while we ran our program, sometimes it ran something from thread A, and again sometimes from something from thread B. Do you remember that program? Let me show you the code again in order to maybe which program did we run? Okay, in this program there are two threads, thread A and class A and class B. A thread is created by extending the thread class. There is another way by implementing the runnable interface. So you see there are two threads, thread 1 and thread 2. So while we ran this program, it showed us sorry, it is in this computer. Okay, thank you. Okay, so here what you see that our codes are very simple. I have created two threads, thread 1 and thread 2, and I am starting thread 1 by calling thread1.start method, and after that I am calling thread 2, okay, by calling thread2.start method, right? So apparently it seems that my code, all of my thread 1 codes will be executed. After that, my thread 2 codes will be executed, right? It seems like that, right? But it is not. It was not, and it is not, and it will not be like that, because there is no guarantee that the first thread will start and it will finish, and then second thread will start. In threading, in multi-threading program, there is no guarantee like that. Sometimes if you see that, so although if I showed another program, maybe that showed you that different output from different thread. Which one is that one? I showed you another program, right? Remember from last class? Actually, maybe I created a thread, multi-thread, or did I? Oh, sorry, I created a parallel process, a multi-threaded, maybe this one, this class. Okay. Yeah, I created a new package and I discussed from here. So let me run from here. Okay. So this program, I have a longer loop from I equal to 1 to 50, and say j equal to 2 to 60. So if I run this program, the similar program, that one, but it has runnable interface implementation. So if I even run program maybe 4, maybe 5 or 6, or which one is 2, maybe 2. Okay, 2, yeah, program 2 and 5, actually 2 has extended into class A. Thread class A is created by extending thread class, and it is similar, like for 5, thread A is created by implementing runnable. same, almost similar. Okay. So then, if I run either of these program, then we'll see some anomalies in our program. We should see, you see that sometime it is running thread A and then it is running from something from thread B. You see here? So while running something from thread A, it is running something from thread B. And while you see that all of course are running from thread A, then it's going to running thread B. And some thread A and thread B. So if we rerun this program again, then I will have another different set of output. So what does this mean? It means that there is no guarantee that for multi-threading programs, one thread will be completed and then another thread will be started. So in this situation, there is a plausible deadlock situation. Okay, it may happen a deadlock situation. For instance, if my first thread uses a data file, and while my thread 1 is executing, for instance, is writing something in the data file. Okay, then another thread may be started that may need to use that same data file. So in that situation, we know that once an operating system does not allow us to use a data file simultaneously by two processes, by more than one process, right? So thread 1 needs to release the data file in order to allow another thread or process to use that data file. So in that situation, a synchronization is needed. Synchronization means that we have to ensure that the thread 1 will be executed first, and it will complete, and once it completes, then it will release its data files or some other elements, and then another thread will use or will start and use that data file. So in order to ensure that, we need thread synchronization. So now let us back. So there are some issues there. You see that it happens mainly, thread deadlock happens mainly for single processor. Okay. So now let us. These are the common scenarios of synchronized threads. Okay. So yeah, please read through these and try to understand this, and you may be asked to write some of these in your test. The characteristics, okay, synchronization characteristics. Go through these two pages. I don't like to read aloud this, so you please read this and try to understand this, and then memorize something. Then I want to go back to this thread synchronization, this diagram again. So now if you do give a close attention, you see, to this diagram, you see that there may have some situation that at certain time, if we do not ensure thread synchronization, there may be a deadlock situation. So this is not the only one situation for deadlock. There may have another or other situations that may create a deadlock. Actually, when you study more about operating system, then you will learn this, and then you will do more programs about threads and multi-threading and parallel processing. But in this class, we just within only one class or two classes, I am just giving you just a brief overview, just a startup, so that you remember that you heard something like this, and you can do more study about this in your next courses. So now let us see that if you say that in Java there is a synchronized keyword for ensuring synchronization, in C# there should have a similar technology, but people who are taking C#, please check in your book. I don't. I will check also. If I find more, then in the next in the review time I will discuss. But people who are taking the C#, please go through and see that if you find something about synchronization in C#. So actually these two pictures, the last two slides, it shows sometimes when we see that multiple threads or programs or processes run in our machine, sometimes it becomes slow and slower. So then we click Alt Control Delete and go to Task Manager. In order, then we see that how many threads or processes are running. You see the threads over here. It shows how many threads are running. Because I don't have a program. Actually, the professor who created these slides, maybe he had a game, multi-threading game running on this computer, on his computer, and he created these slides. So I don't have this, but I want to show you some programs with thread synchronization. Okay. So for your test, so study these two slides, how to synchronize threads. Okay, and what are the characteristics of the situation and characteristics of thread synchronization. So if I go back to my okay, maybe I'm lucky, I got a program. Let me see if I have what programs I do have. Okay, so these are larger programs. I don't like to go to larger program. You see that, for instance, if you clone or download this project, you see that there are some errors. It's showing some errors, like for instance J18_18 on this program. Actually, it is showing me error because this class A is available in other files, so it is showing this error. So in order to resolve this issue, just change this class name. For instance, for this one, you can change this file name as, for instance, this is 8. So I would easily change it from A to A08, and then wherever I have A, then I will put A08 quickly. Then wherever I have B, then I will put B08. Then these issues should be resolved, because Java does not allow to have multiple classes with same name in different files, in same package. So all of these are in same package. So this is why it is showing me this error message. So like if you do like this way, then your error should be gone, and then you can run it. Okay, so then you can resolve this issue like this way, and then you can resolve it. Okay, so whatever programs I was discussing, maybe 18, 13. Okay, so as I mentioned, the synchronized keyword is used in order to synchronize a method. So what is the advantage of synchronizing a method? The advantage of synchronizing a method will ensure that the method, whatever is synchronized, it will be started and executed. After its execution, another thread will be started, and while it is executing, no other thread will be started. Okay, but I believe so the goal in this course to give you just a start about synchronization, because synchronization is needed if you want to develop a more sophisticated or multi-user application. Sometimes I work in an insurance company. So insurance companies, they develop their application in a way that, for instance, if you have insurance with Geico, then sometimes you go to your account, you log in your account, and if you find something that if you are not happy, or if you have any issue about your bill, or if you have any question about your bill, right, then you call the customer service, right, and explain them this is the issue, I have question about this issue, right. Then sometimes that the synchronized, if your program is well synchronized, okay, then sometimes I know one of the like T-Mobile or something, sometimes they will tell me, okay, so I see that you are logged in, so please log out. Then the customer service people, representative over there, they are able to log in. So if your program is not synchronized, application is not synchronized, then two people cannot log in to the application at the same time. So if your application is synchronized, then for instance that issue will not be an issue. So I don't know, for a long time I did not run this program, so let me run this program and try to understand what is happening here. Okay, maybe I got something. Hello Java programmer. Okay, so you see that my main method, I have object 1, object 2, and object 3. Okay, so object 1 has an argument with hello, and object 2 hello Java, and object 3 has programmer. So once I call this program, for instance, if I run this, object 1 dot thread dot join, object 2 dot thread dot join, and then as expected, it was supposed to do show my output like hello Java programmer, but instead of this, it is showing me hello programmer Java. Okay, if I run it the next time, it may show this similar output, or it may show a different order. Okay, I'm not sure, I have to run multiple times in order to see a different output. Or actually, let me see what it has in this program. It has a try-catch block. Within try-catch block, it has a sleep method. It waits 1000 milliseconds, means 1 second. in order to show each, so it's call me method. So when we call me method, it will use thread. It's called thread.sleep method, and then sleep method is waiting for 1000 milliseconds. That means 1 second. This is why that you will see that when I ran this program, it was showing something hello and then waiting 1 second to show this. So the next output. Okay, but in order to explain this program, I need to go more. I need to discuss about like that what I discussed. Maybe I discussed something or showed something. Do you remember that? Yeah. In order to do that, I need to discuss and the thread control methods. In order to explain that program, in order to understand that program, you need to understand how each of these method works and how these are the features. So these are not included in the syllabus. So I'm not going to spend my time, okay, for discussing this. But who are in advanced readers or in your next course, okay, when you face this kind of topic, you can study more on this. Or if you want to discuss or learn something more, you can come to me for one-to-one discussion. I can help you. But for this course, for now, you don't need this. Okay. So mainly what I wanted to give you again another reminder that just study these 2 slides for the test. Okay. For thread synchronization. Okay, understand the thread synchronization and its behavior. Okay, anyone has any question about threading and multi-threading? Okay, so if you do not have any questions, then I like you to go through this I thought I should have multi-threading. Okay. I will update this, okay, and I will push updated code to my GitHub account and then get it and then run it. Okay, so if you do not have any question, then I like to start my today's topic about parallel processing. Parallel programming. So parallel programming is today's day, and parallel processing is related to multi-threading. Okay, parallel processing is related to multi-threading, parallel programming. So Java is a multi-threaded programming language, and C# as well. Most of the modern programming languages are multi-threaded programming languages. That means these programming languages allow parallel programming. Parallel programming means you are allowed to use or run multiple threads or multiple threads mainly, or multiple processes parallelly. If you have one processor then the processor will share its execution capacity.
This is the lab, and then this one's only 2 pages.
Oh, sorry. Sorry, I did a mistake, so I forgot. That's a mistake. Okay, I don't need it. Okay. I will show you some parallel programs. Okay, but these slides, okay, so these slides, whatever this, I think these slides are parallel processing actually related to parallel processors. You know, most of the modern computers have multiple processors. You see the co-processors, you know the co-processors, right? When you take in next courses, you will take microprocessor class and or operating system class. Then you will know more about parallel programming and especially parallel processing. So in your microprocessor class, you will know more about parallel programming. So in most of our computers today, modern computers have multiple processors. And for the concept of parallel processing, there is a well-known theory or law. It's called Moore's law. This law already is proposed by Gordon Moore. Okay, so it is related to the speed and performance of modern and upgradation of modern processors and computer applications performance. Okay, so actually the Moore predicted that in every 2 years, okay, the transistor capacity will be doubled per square inches. Okay, so and Gordon Moore, he predicted his rule. He predicted it in the 1960s, and he thought that it will be continued for the next at that time 10 years, but still it is from 1960s to now 2000, about 20, so about 80, 40, 50, 60 years, right? But his prediction was almost true for 50 years. So as you know that, remember that, so all hardware uses transistor or the chips. The chips capacity raises by power 2, right? Sometimes you will see that your processor's capacity or RAM capacity, for instance, is 8. It started with 4. You know, when I bought my first computer, desktop computer, that was a market-based computer, and it had 256 megabyte. Megabyte or kilobyte? 256. Yeah, something like this. I'm not discussing that. 256 times 256 RAM. Then 520 megabytes, right? 256 megabyte each. The 256 megabyte, I got 2 RAM. That was the best processor. Like 20 years ago. Now then see 256 times 2, 500, it came 512, right? Megabyte, then it came 1 gigabyte. Now it is coming 2 gigabytes, 4 gigabytes, 8 gigabytes, 16 gigabytes. Now we have RAM about 16 gigabytes, right? Up to. Maybe within a few years you will get 32 gigabytes and then maybe terabyte sometime you will get. Yeah. So actually the Moore's law is predicted that it will double the hardware capacity in every 2 years for the then next 2 years, but it is happening sometime more than double. Okay, and it is happening for the last 50 years, and then the question is that the research question is that while the processor speed is doubling, right? So then is it true that our application speed is doubling also as well as? No, because there are some other things associated with our application, right? For instance, that he mentioned bus speed, right? Processor speed increased tremendously, but there are other accessories, related accessories. Those accessories speed did not increase or at that level. So sometimes you see that while you cannot exactly expect that if you have a double speed processor, then your program will take half of the execution time. This is not true, because there are other related things that depends everything for the performance. Depends for the performance, related to the performance, right? Okay. So Moore's law, you will learn about Moore's law when you run when you go through other advanced courses, mainly microprocessor. You take microprocessor course or operating system course, you will learn this. For instance, creating new application for predicting weather, and while in case you need to handle with big data, then these rules and this prediction are sometimes applicable and measurable. And then, although Moore's law was mostly related to hardware engineering, but it has some implication about software engineering in terms of parallel processing. Sometimes you will see that in your advanced courses, you will see that you can use your multiple processor in order to run your program, multiple threads or multiple processes in your program. So for the test, go through these slides. Few slides. There are only 3 slides. Okay, there are only 3 slides or 4 slides. These 4 slides: 1, number 2, number 3, and number 4 slides. Read through 4 slides and remember its summarization. Whatever you understand is summarization. Remember this, okay, for your test. But I like to give you a heads up about parallel processing. That is my goal for tonight. Yes. It is from lecture slide. What is your question?
Like the lectures have a number, right? We have seen lectures when is it part of the lecture?
It is, let me see it. It is lecture 20. It shows on the slide, you will see it is lecture 20. Parallel and Java. Okay. but I want to give you some real example of parallel processing. So I want to add another slide, parallel processing in Java. Okay, parallel processing in Java. I want to add one more slide over here. Let me go through your class D12, right? Go to your class D12 and quickly for this class, actually I will add it later. Okay, so I will add this slide, okay, parallel processing in Java in the course content here. When you go to the your course, and in the content area, so you see threads and parallel processing. Okay, so then I can add one more. I will upload this my file, okay, so that you can get it. It shows that is opened by another program. Okay, I have added this one. Lecture 22, parallel processing in Java. Okay, so after this 21 is missing, 23. Okay, I added this one. So if I go through this one, if I go through this one, you will see the actual flavor of parallel processing. Okay, so this is the presentation I gave at the time of my interview here. So I'm giving it 20 minutes. It will take 20 more minutes. Okay, to give. We have 20 minutes to give you a result. So as we know about parallel processing, right? So how to implement parallel processing? We know there are two ways. One is by extending the thread class, and another is by implementing the runnable interface. The two ways, right? So there is a well-known and recent technology. It's called fork join pull technology that is used for parallel processing in Java. So in this short lecture, I will give you an overview about fork join pull structures and its functionality, and some steps how to implement a Java program with fork join pull. Okay, just quick. So this is the structure of a parallel programming. So in parallel programming is a process of running multiple tasks on multiple processors. So in actual parallel programming, okay, so multiple tasks or processes are executed on multiple processors. For instance, I have I have 4 CPUs. I have 4 CPUs, CPU 1, 2, 3, and 4, and then I have 4 different processes. Processes means some 4 different programs, functions. Okay. So then in parallel processing means, okay, so you see that maybe each of the individual processors will execute different processes. So as we know that we can implement multiple thread by extending the thread class or by implementing the runnable interface. We showed that, right? There is another older technology in Java that is called Executor Service in Java, that is also used as asynchronized execution mechanism. Asynchronized means that did not ensure that no deadlock will be occurred in asynchronous technology. So the Java Executor Service is up and popular for a while. So it segments the task, and it has a task queue, and each of the segmented tasks are sent to the task queue, and there is a thread pool. That thread pool receives thread tasks from the thread queue. And as we know that for QE, whatever task is going fast, that is executing fast, right? QE is a fast in, fast out, FIFO type memory, right? Or application. So in order to resolve some issues in executor service or thread programming in Java, there is a new or another lightweight or similar technology, better technology is Java. It is called fork join pool. So in fork join pool, whatever it does, actually it splits a larger task into some smaller task, and then finally it combines the final result together. Like for instance, what we do, we learn about the recursion method. The recursion method splits its task, right? It recalls itself. The fork join is more similar with recursion. So what it does, if a task, then the task is the fork part of the fork join executor, it splits the task into some subtask, into another some subtask, and then it gets result. Each of the small tasks are executed, and then results are combined using the join technology, and then finally all sub results are joined together to make a new or final result. This is the concept of fork join. A task is split into multiple tasks, and multiple tasks are executed through multiple processes or processors, and while each of the subtasks or smaller tasks are executed, all the results are again joined in order to find the final result. This is the fork join technology. So this is more similar with divide and conquer fashion. Divide and conquer fashion is a well-known technology algorithm. When you take algorithm class, you will learn about DC, divide and conquer algorithm. Okay, so I don't have time to discuss this, but what I want to show you how to create a fork join application. A fork join application, it has mainly two methods. One is fork method, another is join method. Fork method splits the task, and join method, they join the result. Just I want to show you an example. For instance, we know how to create a Fibonacci series, or nth Fibonacci, or a factorial. For instance, let us try with a Fibonacci series. How do we find like fifth Fibonacci? number in the series, right? For instance, we have a base. If n is less than or equal to 1, then we return 1. Otherwise, else we call, for instance, Fibonacci f1 equal to new Fibonacci n minus 1, and we are splitting this f2 equal to new Fibonacci s minus 2. That means we are dividing this Fibonacci n into two parts. Fibonacci 1 n minus 1 and Fibonacci n minus 2. And then we solve f1 individually and f2 individually, differently, separately. We solve this subtask separately, and finally we combine the result. We aggregate the result. Then we finally get the result. So apparently for this small program, it does not make good sense, but think about for a large, very large and high data processing program, it is a good way. Okay. So then I want to show you, so quickly I want to show you, this is a complete program of fork join using Fibonacci for finding Fibonacci nth Fibonacci number. I want to show you the performance of the main interest or interest of using parallel processing is to speed up, right? It is speed up our application so that we can execute our application faster. So this is a complete program, how to create a Fibonacci, a Java program with fork join pool is parallel program. This example just for finding nth Fibonacci number. Okay, this is a complete program. Just I will show you that, for instance, this will be the output. This will be the output. For instance, I will show you how to run this program. And if you see that if I want to find the Fibonacci 20th Fibonacci, what will be the 20th number in the Fibonacci series? Okay, and then if I want to find it 5 times, that means I want to run this same application 5 times. For run 1, run 2, run 3, run 4, and run 5, you see that for same programs, for different runs, it took different amount of time. For instance, for run 1, it took 16 milliseconds. But for run 2, it took 7 milliseconds. For run 3, it took 5 milliseconds. Okay, but for run 5, it took 8 millisecond time. This happened because due to using the fork join pool. I created a fork and join pool. Okay, fork method and join method. That I use fork method and join method to create a fork join pool in order to execute this program for 5 times, and it showed me that it is the actual beauty of using fork join pool, that sometimes it shows that different runs have different execution time. Just if you go to my okay, if you go to my maybe parallel processing fork join. Okay, fork join parallel processing. So if you go to my here. So if you go to my GitHub account, if you go to my GitHub account, CSE1322 expert GitHub account, then you will see I have a repository. It's called either parallel processing, if you go parallel processing, or fork join parallel processing. So if you clone this project, so for join parallel processing, this is the project here. For join parallel processing. Okay. So let me show it. So here in this part, I have this Fibonacci. Just I rename the class name as from Fibonacci to nth Fibonacci. Okay, and okay. So you will not have any question for your exam, for your test for this one, but just I'm giving you a heads up so that you remember that when you take your advanced level class. When you need that, you can come back here and you can get it. Okay. For instance, here I have to run this program command line. Okay, so this is my program, but if you run this program from here, it will not run. It will not be executed. Okay. So actually, I need to run this program on command line. So how do I run this program on command line? So first of all, I need to go do a right click and then show in, and then I need to go to click on System Explorer. Then I need to see where is my source file. This is my source file. Okay, this is my source file. So then I need to open a command prompt and then CD and then Control V. I'm going to my source folder. Okay, and then I need to use Java compiler to compile this program manually. Java, then I need to write the class name. This is Java file name. Okay, nth Fibonacci.java. This is the way I used to compile my programs when I wrote my first edition of Java book. At that time, we did not have any what is it called, Eclipse or NetBeans. So this is a way to compile program. Okay, so Java and then nth Fibonacci, that my Java program name .java. Okay, so then if I press enter, okay, if it does not show anything, that means it has compiled correctly. It has compiled correctly. See, it has compiled. It has compiled means it's created a class file. Then how do we run this class file? Then at this time you will need to write Java. Okay, not Java interpreter. You need to use interpreter. Java, and then you need to give two arguments over here. So in order, according to my program, it says the first argument will be argument 0 will be the nth Fibonacci, that which Fibonacci you want to find, Fibonacci number you want to find, and then second is execution time, how many times you want to execute it. So let us do it like fifth Fibonacci number, and then let us run it 7 times. Then 5 space 7, 5 is the fifth Fibonacci number, and 7 means that I want to run it 7 times. See? Can you see my output? This is the Fibonacci 5. Fifth Fibonacci is always 5. Fibonacci series start from 0, 1, 1, 2, 3, and then 5. Actually, some people say 0 is not the first one, it starts from 1. So this is from 1 plus 1, 2, 2 plus 1, 3, 2 plus 3, 5. You see that for first time, sometime it took 15 milliseconds, and again it took 1 millisecond, again it took 2 milliseconds, and sometime it took 1 millisecond. So different run took different time. Okay, so this is an example of how to write command line argument command line argumented Java program, and how to execute that, compile that and execute that. Actually, you know, this is maybe the good time when we write our main method. We always give this argument like string array args. This is the time I used args. This is the args. Args is an array, and I'm putting args 0. That means the first argument. This is the first argument, except the first two. This is the Java interpreter name, and this is the file name. So instead of these two, so my 5, whatever I give 5, this one after space, this will be the argument 0, and this 7 is argument 1. Okay, and then if I run this program, make it similar to my 20th number of this series. Okay, and then if I run it 7 times, then it will give me 20th number of this series 6765, right? Is this 6765? Yeah, 6765. And it took, here it took 16 second highest and 5 millisecond lowest time. But this time it took, you see, 74 millisecond highest and 2 millisecond lowest time. There is no guarantee that it will, how long time it will. It depends on how many segmented it did. So the speed is dependent on how many like small segmented subtasks are created. The subtasks, how many subtasks are created, are defined here. You see that how many subtasks are created here by using, somewhere it will use fork method and then join method. The last 2 lines here, maybe I can show you here on this my code. You see that here is fork method is used. Okay, so because my F1 is Fibonacci number, okay, and then it is recursion method, and then it is calling F1.fork, and then finally, and it is creating another Fibonacci object, and it is returning this one, F2.compute plus F1.join. It is so it's related to both recursion and fork join pool. So for this course you don't need this, but remember that when you take advanced level computer science course for operating system or maybe you have not heard it yet, is a single instruction multiple. Have you heard that? SISM, single instruction multiple single method. You have not heard that for you did not take any microprocessor class, right? Is there any senior level student here or junior level student? Okay, so you don't need this. You understand this. Okay, another thing that if you want to execute this program, okay, so if you may find an issue. The issue is that in order to execute your program on command line, you must have to set up your Java path, is this path, Java JDK bin path to your, like this, to your last minute, to your environment variable. So for instance, if you go to my computer or this PC and do right click, application properties, and go advanced system setting and to environment variable, and you see the path command. This path, if you do not have this path set up, then for instance, let me delete this path. Okay, and then make it okay, and then okay. Then if I want to run this program, it will not execute it. It will not be executed. You see that I will get an error. So what is the error I will get? Let me show you and run it. Okay, so System Explorer, and if I go to this folder, CD, Control V, and let me write the same command again that I executed a few minutes ago. Java nth Fibonacci dot Java. Then it will show me Java. You see the error message? Java is not recognized as an internal or external command. That means, what is the reason of this error message? That I do not have my system environment path set up here, environment variable path set up over here. Okay, so in order to do that, okay, I need to go to C drive and then go to program files, then go to Java, and then go to JDK. You must have go to JDK and then bin folder, and then you see that here you have Java here, Java compiler here. So then you need to copy this entire path, Control C, copy, and you need to create here path, PATH, all in uppercase, and then paste over here, and then press OK, and then you press OK, and then again OK here. Now you need to close your terminal and open it again. CD of space, CD, what is my program name? Actually, I can go quickly together here. I can go quickly this way. Actually, CD Control V, it will go to there. And now if I do Java, if I execute that Fibonacci dot Java, it should do. So it is working right now. And I can execute my interpreter. Java Fibonacci by 5, 7 times. It's running. Okay, if you try to do this practice, then you will be a step ahead. I have a video for if you face this problem, how to resolve Java is not recognized as an internal or external issue. I have a video. I have uploaded a video on my YouTube channel. If needed, you can watch this video, and in order to execute your command line argument program. Okay, good luck and good evening, everybody.